All right, section 5.4 is on the slope formula. And I have to write something in here for the slope formula. I got to have my little division line. Okay, so this lesson shouldn't be that hard. The key points to this lesson is keep your points together. I should say in the same order. That's key number 1. And key number 2 is to keep the y's on top. So what they want you to do in this lesson is to calculate the slope, either given some points or off of a graph. So I figured off of a graph, they give you the points also, so we'll just do it all in one step. If we look at this first graph here, it's measuring the time worked and the money earned. So after working 4 hours, this guy earned $80. So we know that he is making, after 2 hours, 60. After 0 hours, it's 40. Well, that doesn't really make sense, does it? If he didn't work any hours, he shouldn't get paid. But so this part, when we talk about domain and range, 0 would not be in the domain of this function because that wouldn't make sense to us. So, but the other points are 12 and 160 and 4 and 80. So by looking at the 4 and 81, we know that he's making $20 an hour, right? Okay, so if we're calculating his slope, we're going to go and look at 160 minus 80. So we're taking our two y coordinates and we're subtracting them up on top. So we're putting the y's on top, and then we're putting the x's on the bottom. And this is what I'm saying is keep your points together. If I started with 160, I need to start with 12. 12 minus 4. So 160 minus 80 is 80. 12 minus 4 is 8. And I get $10. What did I say here? $20, right? So we know that this is not a proportional graph. And the other way we could tell that this is not a proportional graph is it doesn't go through 0, 0. If it was proportional, it should go through 0, 0 and those points, but it's not. So our slope of our line is 10. So how do we get that point of after 4 hours we earn $80? Well, if you look at the y-intercept here, that y-intercept says he's going to start with, as soon as he goes on a job, he's getting $40. This would be like a plumber or an electrician. They have a base fee that they charge, and then they charge a per hour rate. So this person charges a base fee of $40, and then he gets $10 an hour for doing the work that he does. Okay, but the point is that this slope is calculated, and that $10 stands for the amount of money he earns per hour. And so that's basically what they want you to do. They want you to calculate the slope and interpret what it means. So 4860, comma 9, 1620, comma 3. This is the number of peanuts and the jars of peanut butter. So 1,620 peanuts make 3 jars. 4,860 peanuts make 9 jars. And we subtract our y's, 9 minus 3, and 480 4,860 minus 1,620. And we end up getting 6. And I'm going to have to use my calculator because I don't want to think that hard today. So 4860 minus 4860 minus 1620. And obviously I can't work my calculator either today, but so we get 6 over 3,240. Now, does 6 go into that number? Yes, it does. It goes in 540 times. So for every 1 jar of peanut butter, we need 540 peanuts. Now, if we look at this and we see that the graph does go through 0, 0, so this is proportional. And we could also calculate that out by looking at the ratio of our y to our x here. And this ratio is 3 divided by 1620. How about 1620 divided by 3? And I get 1 over 540. So our proportion and our slope are the same. Therefore, it's a direct variation. Okay, does that make sense? Yes, Mrs. Reed, it makes perfect sense to us. All right, so the slope of a line is the difference of the dependent variables. Guess I probably shouldn't go on to the next page, huh? The dependent variables divided by the difference of the independent variables for any 2 points on the line. 2 points lie on a line when you substitute their coordinates into the slope formula. The value of the denominator is 0. Describe this line. So we talked about this as one of our special lines. And when we don't have, or when we're climbing that vertical cliff and we don't have any gears, it's impossible to climb the vertical slope. So that is a vertical line when we have a denominator of 0. So I just wanted to talk about those a little bit. Now we're going to move on to another example. And this is one that might be in your assignment. So you know to go to the notes and get this down. So the graph over here on the right shows the distance traveled by 2 cars. Which car is going faster and how much faster? So we're going to take a look at this point because it's crossing the hash marks there, and this point here because it's also crossing the hash mark. So we're going to compare those two cars. Car 1 has coordinates 0, 0 and 160. And car 2 has coordinates 0, 0 and 140. So if we look at the slope, 60 minus 0 over 1 minus 0, we get 60, and this represents miles per hour. And this car down here is 40 minus 0 and 1 minus 0, so that's 40 miles per hour. So which one's going faster? Car 1 is going faster. By how much? 20 miles per hour. How are the speeds related to the slope? Well, if I look at rise and run, 60 over 1, 40 over 1, the slope and the speeds are exactly the same. At what rate is the distance between the 2 cars changing? Okay, at what rate is the distance between the cars changing? Rate. What do you think about rate? Rate is that ratio of like things, 60 over 40, which reduces down to 6/4, which reduces down to 3/2. It's, if we do that, it's increasing at a rate of 1.5 miles. I should say 1.5 times as much. So car 1 is 1.5 times the distance from car 2. That's really all there is in this section using that slope formula. You've used it before in the past. Y minus y over x minus x. Do you need to worry about which point is the first point and which point is the second point? No, you don't. You pick it and you decide, as long as you keep things consistent. Remember, whatever you start with up in the y, your x coordinate that goes with that point has to be the first one that you start with in the x.